So yeah, let's just do a quick little review. It'll be on 3 sections. And the back part of today, we'll get into the 4th section, but it won't be on this exam, or the take-home part of this exam. It'll be on exam number 2, which is like 4 weeks away or something like that. And it also won't screw you up. It won't like mess you up by looking at something new today. It's different enough that and anything that is mathematical will be tied directly to what we're doing for these exams anyway. Everything builds on itself in here, which is super nice. So the sections you want to look at are intro to prob and statistics. That's your first problem set, your first homework set. And I'm glad Cassie said what she said about the homework sheets earlier too. It never hurts to see it again. Honestly, it doesn't. It never hurts to know where that link is and look at it again, because you guys have only been here for 3 weeks. And chances are, this is the most goofy setup of a class you've ever seen before. Most things are either in Blackboard, they're very, very, very logical, or not logical, they're very linear. I'm definitely not linear. Very logical, but I'm definitely not linear. So it never hurts to look at it again. Second section is measures of center. And then, we just kind of got done asking some questions, and you guys asked awesome questions on it. There's measures of variation. Fantabulous. So what I want to ask you guys right now, oh, and by the way, just to throw this out there, I have 2 243 classes this term. You guys and the one I have at 10:15 in the morning. And inevitably what happens is, folks, when we go over homeworks, ask different questions. And also, due to what you guys say in class, I go off on slightly different tangents that tie into it. So it might be helpful for you to not just look at your class, but also look at the other classes as far as like skipping through. We might say something in there we didn't say in here, or vice versa. So if you need more, just go check out like the beginning or the end of their classes and see when we especially at the beginning. That's when we go over homework in the beginning. So you can go right to the first part, and then you can kind of play it from there. So just put that thought out there for you. Okay, grab anything you remember from any of these topics, and let's chit-chat about it as a quick little 5 or 7 minute review here. Anything at all, no matter how general or how specific. Go ahead, Austin.
Central tendency.
Central tendency, good. Anything in there. Well, central tendency and measures of center are kind of synonymous as far as, what's something from there?
Well, I watched your video because I missed that class, but I didn't still really understand.
What are the measures we're talking about? What are the measures that were in that video that we used?
I watched it this weekend. So.
Oh, okay, so it's been a couple days, right? Help them out, friends. Average. Median. And the third? Right, the mostest. There they are. Know how to calculate them. And when I say that, what do I mean? Know how to use your technology. We've already done these by hand enough times, Kelsey, yes. We did Bert. We did Ernie, we didn't do Bert. We did the keys. We did something else in that day, that first day of that central tendency. Yes, we're done doing that stuff by hand. There's no reason to do it by hand anymore. So use your technology. The mode is the only one the TI doesn't do for you. That's one you have to kind of scan through and analyze. But you got some tricks. You can do the sort of the data to put things in order, look at the highest bar on the histogram. There's all kinds of ways to figure out what the mode is. Cool. So that's essentially what I'm talking about with there, is just make sure you can actually calculate a mode, a median, and an average from a data set. And I also, just so you know, for whatever we talk about for these guys right here, make sure you can do it on raw data and also grouped data. So if I give you a block of numbers, like an actual block of a data set, make sure you can do it on that block of a data set. And if we have something like we just did, that lesson we just did was thank you Tabitha again for that one. That was a great one to look at. When you had the histogram given to you, you had to pull the data off of the histogram plus the frequencies. That's a weighted average. So, and a weighted median for that, and a weighted mode, I guess, for that matter. So making sure you can actually pull that data from a distribution or a histogram, either one. Cool. This is kind of strange. I have measures of variation with nothing under it, but an arrow coming up the top of it. What's the one from in there that we like to talk about a lot? Pretty much the only one. Go ahead, Shelby.
Standard deviation.
My friend, absolutely. Your sample standard deviation, lovingly called S. Lovingly called S. As far as the empirical rule goes, don't worry about memorizing it. Back to Raphael's awesome question about should I memorize this, should I memorize that? Don't memorize anything. I am going to cue you. I think I'm probably going to include, just because we talked about it today in both classes, the 95% is within 2 standard deviations. So just make sure you knew how to do it today, which makes me think you're going to know how to do it on Wednesday as well. But what 2 standard deviations means, right? When we say 2 standard deviations, just know it means x bar plus or minus 2s. And I might even put that on there. I may even put that definition on the exam. Just make sure you can calculate it. So make sure if you have x bar and you have s, that if you see something like that, it doesn't make you vomit inside. You know to double s and then add and subtract it from s bar and create a range of values. Just like we did in class last time. We did that weight loss data set. We pulled the weight loss from that article and we set up 1 and then 2 and then 3 standard deviations. And I won't do 1 and 2 and 3. That's a little ridiculous. But I like 2 only because 2 gets used in industry so much. Cool. What else you got? What else do you remember?
Internal.
Absolutely, Shelby, absolutely. Give me something in here. What should we have on the exam in here?
Qualitative and quantitative.
I'm going to leave that off, I think. No, that's in there. You've got that. It's correctly, that's in there. But you guys, on that quiz we took, you already kind of, rather than filling your head with definitions, which I don't want to do, since you already showed me mastery of that, I think let that go. And we talk about it all the time in class too. It seems like overkill to do that and everything else. So let that go. What else was in there? Go ahead. This is
histogram.
No. Damn it. I wonder if it's because I have a cousin named Matt who has a brother named Drew. I wonder if that's what's throwing me off. And Drew looks like Nicolas Cage. Matt looks like Ben Stiller, which is throwing me off even more. Like neither of those guys. Sorry, dot plot, yes.
Stem and leaf, histogram.
Don't worry about that, only because I want to come back to those. Great questions over here about dot plots, stem and leaves. I want to come back to those. We haven't talked about them in about a week and a half, and I think with that much time off, I want to revisit next week and maybe start on the next exam. But rather than bringing that back from the dead, let's leave that off. Just histograms I like, although I would never ask you to draw one of those by hand. You do them in your TI. So don't sweat that stuff right there either. What else? What else from in there that I will have you sweat a little bit? Not literally. Sweat, hopefully. What else was in there? Ideas.
So we're not going to be doing any of the graphing of the bar graphs that we're
No, because, well, yes, but not on this exam to draw and hand into me. We're going to be constantly graphing in the class. And you're going to be generating graphs on your take-home part of your exam. That's a big part of your take-home exam is actually making graphs and making charts. So that's a better technology to kind of get to learn than drawing, hand drawing what he's handing it in. Plus, I have you kind of play with the histograms on the quizzes. So don't worry about that particular bit for the take-home on Wednesday. I'm trying to make it micro down to just what we're doing on Wednesday then. What else? What else do you remember? Go ahead, Lucas.
Like different percentages, and like, is that what we're going over?
Percentages, what do you mean?
Like percentages of how much a certain data set takes up. I don't know.
Oh, the 6895 bit, that was over here.
No, I know that, but I mean like having data. I know there was this one question you asked, like out of 100 things, like what percentage?
Gotcha.
I don't know if that's what we're doing.
That was that quiz from a couple weeks ago, I think. Like, here's a big data set. What percent are greater than 50, whatever that was. We'll come back to that. That was a primer quiz for the entire course, and we're not trying to get into that today with where we're headed next. So don't worry about that. I'm thinking of one particular group of ideas in particular. That's it right there, Athena. The idea of a margin of error, because I'm not going to make you define these things. I'm not going to make you define these things. But let me throw some terms out here. Margin of error, for sure. I know. Margin of error. I'm going to throw out a couple other things too. Parameter. Statistic. Sample. How are those all related? How are all those things related to each other? All of those have a nice interlacing. How? Grab one of them, tell me what it is. Any one of those things, grab me and tell me what it is. Actually, don't grab me, grab it. Get arrested.
Sample. Is that like a populace that you're grabbing?
Good, so, good. You're interested in a population. Actually, put population on there too, what the hell. Population. You're interested in your population. You want to know something about them. You want to know, on average, what their LDL reading is after taking this drug for a cycle, a 9-month cycle. Why don't we just go out and measure the entire population? Too difficult, too much, too big, no enough resources. Boom. So what do you get instead? You draw the sample. So what I'm going to have you do is, well, let's keep going. You draw a sample, okay? What's this? Say that again. Good, Kelsey. This is the measure that you're interested in the whole population. So you are interested in knowing, for example, what the average LDL level is for a 35-year-old male who's taken this drug for 9 months. But you're never going to know that, are you? What are you going to know instead? What's this class called? You're going to know that. That's why it's called statistics. Because you can't know that, but instead you know that. What is the statistic? It's the average in your sample. Perfect. In case you're having a hard time keeping that straight, parameter and population both start with P, and so does sample and statistic. Start with, well, actually it's both the same one, not P. You start with S. Sorry, this is English. I'll still go with the English, as I've told you before. So, but the problem, of course, is your statistic doesn't equal your parameter on average. So what do you have to attach to your statistic to cover for it? Boom! That's how it's all related. You want to know this of this. You can't. So you take that, which gives you that plus or minus that. Now that's a lot of this, that, and pointing. So here's the way I'm going to set this problem up. I'm going to give you a block. There were a couple problems in your homework. I think we even talked about one of them in class, where it says something like 42% of, I don't know, 42% of 40-year-old Americans had chicken pox between the ages of 0 and 8. Just make this up off the top of my head here. Okay? We think, and that was the number that was gotten in like 1986. We think it's changed now. So we go out and we randomly select 2,000 40-year-old American males. And we find that only 35% of that sample had chicken pox from age 0 to 8. But there's a margin of error on that of about 3%. So basically, I've given you all these things within that block of text. What I will then do is, I'll put these 5 things on one side of the test with 5 blanks, and on the other side, I'll have it matching. So I'll put, for example, 2,000 American men selected. A. That'll go. Not the ones who are selected, that's the sample. Underneath that, I might have American men of age 40. That's your population, right? And then I'll put plus or minus 3% or something like that, which would be your, exactly. Now here's the tricky one. Think about this, what I said. It's not tricky, I shouldn't say it's tricky, it's subtle. I said that from the previous study, it was thought that 40% of American men had chickenpox. Of our sample, 35% did. So if I put 40% had chickenpox, 35% had chickenpox, which one would go where? The sample would be the 35, which means the parameter, excuse me, the statistic, would have to be 35, which means the parameter would have to be the 40. And that was the belief. You weren't given a margin of error. You never are when they report it like that. So if you're not given a margin of error, you have to assume there is none. And it's actually the entire parameter value. It's a bad assumption, but chances are the sample was large enough that the margin of error shrunk down to basically 0 anyway. So that's how I'm thinking about running that problem. It's just as a matching setup. It's easier for you guys because it makes you understand what these things are, but not regurgitate them back. You have to get them in context. Does that ish make sense? So there's a bunch of homework problems that are like that. Just make sure you go back and look at those again, in those particular ones. And the only other thing, I found a really cool graphic I want to use on the exam. I saw it in National Geographic about 2 months ago. It was entitled What We Eat. And it's all about the food that's consumed worldwide. And it's this really neat look at it via a really cool geometric construct, kind of like the one from your homework with the balloons and student debt, ballooning student debt. Let me pull it up here real quick so you can see it. So let's fire it up. So back to here. Variation homework. So this one right down here, this ballooning student debt example. Another one down here, this results by party, this guy over here. All these are good examples of how to present numerical data in a visual context and then analyze to see whether or not a good job was done in that presentation. So make sure you look at those and see the arguments that I'm putting forth as to why I think they either are or aren't good indicators. And I'm going to set up the National Geographic one so that it's more of like a step. It'll have like 8 subparts. So basically, it'll say like, for example, in 2003, how much student debt was there? You'll go, okay, 2003, oh, 62,000. So that'll be one question, a couple points there. And then in 2007, how much student debt was there? Well, actually, it's 2006. 77,552. What's the percent change? I'll tell you how to do that. So basically, it's basically stepping through, pulling data off of a chart. Don't worry about doing the math. I'll guide you through the mathematics. It's a bunch of little divisions and percentages and things like that. Don't worry about the mathematics. Just make sure you understand the arguments I'm putting forth in these problems. And that question will be a piece of cake for you. I'll set it up nicely for you. I got good graphical setups for you guys. Cool? And I like that in particular because this stuff comes at you all the time. Like I said, I was just looking at this one 2 months ago in National Geographic. And it's just like one more example of presenting data in a non-standard way. But you always have to ask the question, was it presented properly? Right? Was it presented well? And that's what you'll answer in the example. Cool?
Yes.
Good. Fair? So there's your example, friends. Put this up again. Yeah?
Sweet.
You're going to crush it. You're going to crush it. I mean, again, I'm going on anecdotal evidence, teaching this course for over 15 years. And I get a beautiful skewed distribution on these exams. Because you guys, I like giving you this because it gives you a refined look. Don't go look at every single thing. For example, do not memorize Pearson's. Sweet Jesus. Do not. Do not. If I ever was to give you anything like that on an in-class assessment, which is highly suspect anyway, but if I ever would, I would give you that entire setup of the problem on the exam or on the board. I would never require you to memorize that. That's a good way to kill any interest in mathematics, is to make you memorize stuff like that. Fair? You guys have any questions at this point about this stuff?
How extensive is your test going to be as far as like questions and stuff like that? And
When you say like how many?
yeah, how many?
Great question, great question.
All day doing it pretty much like for
Well-
throughout regular class time, or is it going to be?
It will not take you the whole time.
Okay.
I budget to make the exam roughly an hour. So basically you come in, you knock it out till about now-ish, maybe a little bit less.
Okay.
And then we'll pick up where we left off today.
Okay.
And we might not even finish that on Wednesday too, which is totally fine. It will not take you the full hour.
Okay.
As far as how many questions, that's another great question. I try to shoot for about like between 10 and 15 total questions that are all like 4 points-ish, somewhere in there. Like the first question, this is an oddball. The very first question, I'm envisioning this National Geographic one to be the very first one. And that's going to have like 8 little subparts, but they're rapid fire. They're like, you know, how many of this? How many of that? What's the ratio of that to that? I mean, it's real rapid fire. This one, I count this as 5, but again, it's matching, so it's not really 5, it's really 1. So this might be the worst possible question for me to, or the hardest possible question for me to answer. No, it's a great question.
Yeah.
It might be a hard question for me to answer because this is kind of a fluky one. I shoot first. I don't try to test you to death. Like I don't want to give you 8 million questions in an hour and be like finish quickly. I've seen people give exams that are like 100 multiple choice questions in 2 hours. It's like, yeah, what are you learning? I mean, what are you learning from that data? So this is hopefully I've given you enough time to kind of sort through it. And really, I'm not after trickiness on this exam at all. I'm just after big concepts. The take home, you have a lot more time. I ask you to explain your thoughts. One of the questions of your take home exam is, on average, how many eggs do my chickens lay? How would you answer? It happens all the time to me. I tell people I have chickens. How many eggs do you get? And what you'll analyze on that take home part, the first question of the exam is, it's a great question because there's so many different ways to answer it. You can answer it purely on average. You can answer it on moving average. You can answer it on mode. But you can answer it time series, which is depending on what time of year you ask me. So that's why I don't like those for in class though. It's too, if you will, open-ended. And I know you guys are used to math exams where x equals 2, and I don't want to torture you with gray on the in-class parts. But if I give you a block of data and ask you what the average is, there's one average for that block of data. So that is black and white. You know, it's on or off. It's binary. So I try to keep these more in that range on the in-class. Again, just trying to look out for your mental health as far as, I know what math exams do to people. I do. I know what they do to people. It drives people nuts. And you know, I don't want that to happen. I want it to not be, hopefully, insanity-inducing. Yeah? Any other questions? That was a good one. Very good, Raphael. It's a tough one to answer on this exam, but hopefully we did it some justice.
Yeah, no, absolutely.
Cool, cool? You guys are going to crush it. I'm not worried at all. That doesn't mean don't prepare. You color the performance. Don't worry about it. You're great. Don't even show up.
Doing me fun.
Don't even show up. Everything's going to be great. All right. So now, everything we talk about from here on out, we'll, if you will, quote unquote, cover on the next exam. And we're not going to finish this today. And we might not even finish the discussion on Wednesday. We'll see how time goes. It might take us till next month, and I'm totally cool with that. I'm in no rush. Say that again.
I said I have one child in the 95th percentile and the other one in the 20th.
And this is what I want to talk about today. And I like the max context of it, only because it's probably the modal context for people in this room. Now, there are other applications. Here's what happened at Max's second year checkup. He's 5.5 now, but I love using his second year checkup because of what happened and the fact that I still have these values. I still have these values from the second year checkup. So what happened was, he always almost inevitably goes to the doctor when I can't go. He's like doing it right now in the middle of class. So my wife, Jen, brought these numbers home. He was in the 80th percentile for weight. And just so you know, there's some shorthand for percentiles. Big P sub 80 means 80th percentile. Just don't have to keep writing 80th percentile. He was at the 90th percentile for length. The 85th percentile for my favorite year's head girth. So, and as Max is asking you right there, what does that even mean? Like from this, how much does Max weigh? How much does he weigh? How long was he? How girthy was his head? I mean, based off of these results, what are those absolute values? And I know being absolute value and absolute value in mathematics. I mean, what is this weight to the nearest pound? Can you tell?
No.
You can't tell. That's the problem with this. Now, it's a problem, but it's hiding something that's even cooler. The problem that we don't know is weight is one thing, but the fact that it's actually hiding, what does it mean to be in the 80th percentile? Some of you may have heard this before. Go ahead, Tim, you've heard it before.
Means that he is weighing his weight. 80% of the people are less than his weight.
Perfect. That's exactly what it means. How many of you have heard the word percentile before? Okay, very few of you. Perfect. That's why I don't skip this section. In the past, I thought about, everybody knows what percentiles are, skip them. Then I realized that maybe 1 in 5 or 1 in 6 know what it is. So that's why we included this. That's exactly. So rather than just give you a raw definition, here's some data. Do not write this down. I'll post this for you guys later. I'll post this you can check it out later. These are the population. This is a great test review question right here. Population. Population, based on this. Don't call it out. Raise hands when you have it. That's a sample drawn from a population. What is my population I am interested in based off that data set right there? Based off that data set. Don't call it out, don't put it out. Everybody get a chance to kind of think about it. You don't have to vote. You don't have to vote your mind. That's okay if you don't want to. Charlie? By who I mean Colin? By who I mean Cody? By who I mean Corey? What's the population?
Actually, I've only got the sample.
Oh, what's your sample? Give me a sample.
Well, sample 100 randomly selected.
2-year-old American white males. Perfect, perfect. Beth, who's the population?
2-year-old American white.
And it's that simple. If you know, you guys have it. You got it. Corey's got the sample. It's 100 randomly selected 2-year-old white American males. Well, if I sample 100 2-year-old white American males, that means my population is 2-year-old white American males. Does that make sense? Yeah. And the only reason I'm interested in this population is that's what my son falls into. So boom, there's our population, there's our sample. Everything else we talked about, you can't get from this data set. For example, this data set has an average. You could calculate it, couldn't you? I would never give you a data set like this on your exam to calculate. It'd be a pain in the ass. I would, however, I could give you that and ask you to give me the average of that, couldn't I? That would not be too hard for you to figure out the average of. Describe to me how you would figure the average out of this data set. Describe to me how you would. We don't have to actually do it. We can ballpark it. Beth, help me out.
I would put the weights in L1 and the frequencies in L2.
Everybody hear that? Great exam review. This is not your typical histogram in that there aren't ranges of values here. You actually have discrete values. 20 pounds, 21 pounds, 22. Yeah, I'm with you. L1, these values in L2, 1 var stats,
Right.
L1,
L2.
comma L2, boom, done, and you got it. Or L1, L2 data freak list. Cool. So, how would you describe that data set? What do you think? Yeah, Belshade? Belshade? Who says skewed? Who says skewed? Yep, there's definitely some skew to it. There's definitely some skew to it. It's skewing, let me get this right, it's skewing left. It's leaning right, it's skewing left, because the average is going to head this way a little bit, because it's chasing these low weights over here. But I think it's bell-shaped enough. We can run Pearson's. I'm not going to make you do it or memorize it. But, you know, that's the idea with how would you classify it is, you can run the math you want on it any way you want as long as you justify what you're doing. That's the beauty of statistics. And also sometimes the curse that statistics gets is like, you can make numbers say anything you want. No, you really can't. You can make numbers say what you think they should say, and somebody can counter that. And nobody's right. It's just two different ways of looking at the same thing. Good, good. So we got some symmetry, maybe not. We got some asymmetry, some skew, but it might not be so much that it's not bell-shaped. But what we're talking about today has nothing to do with bells. That's kind of what's cool about it. We don't even care if it's bell-shaped or not. So what I do want to ask you guys is, what's that 80th percentile? So let me start with this question. Based on this data, how many of the kids represented in this chart weigh less than 26